Hello, welcome to the second part of our introductory video for FFTSES, for Fast Fourier Transform tool for transient analysis. In this tutorial, you will learn how to perform an inverse analysis, meaning you will know how to convert a frequency response into a time domain signal. We will also show you how to use the different plotting functions to display your results. Once you have performed a forward operation, you can produce an inverse analysis by changing the direction mode to inverse. This invokes the inverse computations. In the Conductors and Profile selection table, select the Conductors tab, and then click Add. In the Quantity column, there is a drop-down list. From this list, select GPR of conductor segment for the first row, which corresponds to conductor number 1. For this video, we will simply enter a value of 1 in both the From and To columns in the segment number sections. Next, select the Profiles tab, and then click the Add button. You will select the scalar potential for observation points 1, 2, and 3 of profile 1. Under System Response Options, verify that Computed, which is the default option, is selected. Then, click on the HyFrigMols Response Files button to extract a system response, which, for this example, would have previously been generated by the HyFrig module and saved in an F21 file. Recall that an F21 file is produced when HyFrig has been run for a given set of frequencies. Now, in SysCAD, we will use the HyFrig model Pole Run 1 for this example. We zoom in and click on the line representing the energization point. From the pop-up menu, we select Characteristics, and the Characteristics window will open. An important point to note regarding the use of HyFrig models with FFTSES is the unit energization value. For this example, the input signal's waveform was defined in the forward operation, so the magnitude of the energization in the HyFrig file will be set to 1, with an angle of 0. Back in the FFTSES application, click Add in the Database Management window. Then select the F21 file that contains the system response, and click Open. Then, click the Create button to extract the system response. Once the response database is extracted, click on the Compute Inverse FFT button to launch the inverse computations. When the computations are complete, the results view will appear automatically. And here you can choose to plot the real part, the imaginary part, or the magnitude of the time and frequency domain results. You can also request for 2D or 3D plots, and you can select between different combinations of linear and logarithmic axes for your plots. The type of axis scaling table can be used to customize how a plot will be displayed by specifying a range of values along one or more axes. In this case, we will specify that the plot should display results along the x-axis from 0 microseconds to 50 microseconds. By choosing the None option in the Unmodulated and Modulated drop-down lists, we are requesting to plot only the time domain signal. When we click the Plot button, the time domain plots will be generated with a time domain range between 0 and 50 microseconds. You can verify the F09 or F27 files for additional recommended frequencies, and this can be done either before or after the results analysis. If new frequencies are recommended, it is advisable to run HyFrig with a new set of recommended frequencies in order to obtain accurate results. We will now demonstrate how animations can be created with FFTSES by using a simple 2D animation. We click the Data Input tab, then we increase the point numbers from 3 to 10, and then we launch the inverse computation. When the computations are complete, click on the FFT21 Data button. The FFTSES Database Manager window appears. Click on the Configuration tab, and then in the first row of the selected column, choose No from the drop-down list. When you do this, the animation options will be enabled. Click on the Create Animations button. The Select Plot Data window will appear. Leaving the default values in place, a 2D animation will be created with 10 observation points from 0 to 150 microseconds. Click OK to open the animation window. To run the animation, click the play button. While it is not covered in this video tutorial, it is noted that it is also possible to create 3D animations, as shown here. This completes our second introductory video for FFTSES, which focuses on inverse analyses. If you haven't already, please be sure to check out our separate initial introductory video for FFTSES, which presents the forward analysis. For further information about the FFTSES application, please check out our how-to manuals or our online help. Thank you for watching.